Do you recognize this series? If you write this out, when n is 0, there's 1 factorial, which is just 1. 0 power would be 1, and this would be x. So when n is 0, you get x. When n is 1, 1 times 2 plus 1 is 3 factorial, so it would be 1 over 3 factorial. X to the third. Yeah, it's the sine series. It's the Maclaurin series of the sine. So, of course, we will be interested in knowing the interval of convergence and radius of convergence because we want to know when this is a valid approximation of the sine function. And we could be asking this for any Maclaurin series. You can write down the Maclaurin series for exponential functions or tangent, arctangent. There are other things that we've done with the Maclaurin, right? Okay, but let's just see how this one works out. Solution, we always use a ratio test. So an is whatever you're adding. And then an plus 1 would be, well, if you have 2n plus 1 and you replace n by n plus 1, that's 2n plus 2 plus 1, which is 2n plus 3, right? So I'm just going to replace the 2n plus 1 by 2n plus 3. And here's what you get. You get negative 1 to the n plus 1, x to 2n plus 3, and 2n plus 3 factorial. If you replace all the n by n plus 1 and simplify, this is what you get. Now, capital R is the limit of n going to infinity of the ratio of an plus 1 over an, absolute value, equal to limit. It's a division of fractions. We're going to use keep, change, flip. So the first one here, we just copy without change. But as you see, I've ignored the negative 1 to the nth power, n plus 1 power, because when you're taking absolute value, that it doesn't do anything. And then division becomes multiplication if you flip this, so then you get 2n plus 1 on the top, and you get x to the 2n plus 1 on the bottom. And this suggests that I want to divide this by this and this by that. Let's switch places. Limit n going to infinity of x to the 2n plus 3 divided by x to 2n plus 1 times 2n plus 1 factorial divided by 2n plus 3. Okay. This part simplifies to what?
X squared.
X squared, because you subtract the exponents, right? And then, what about this one? How does this simplify? It's a bit harder.
2n plus 2 and then 2n plus 3.
Yeah. So see, if you rewrite 2n plus 3 as, what's a factorial? You write that number, but then everything that's less than it gets multiplied, right? So 2n plus 3 factorial is like 2n plus 3 times 2n plus 2 times 2n plus 1, and then so on and so on. And on the top, you start from 2n plus 1, and then you go down like 2n, and then so on and so on. But once you write it like that, you see that, oh, this part is exactly the same as that part. So after canceling all that, this is the thing that's left. So you're going to end up with absolute value of x squared and absolute value of 1 over 2n plus 3, 2n plus 1, 2n plus 2. And I guess x squared is non-negative, so we don't need absolute value there. This is also positive, so we don't need anything. And here's what we get. We get limit n going to infinity of x squared times 1 over, if we multiply this side, it's like 4n squared plus 10n plus 3 times 2 is 6. Okay. Now, x is some fixed number, right? When we evaluate the power series, we plug in a number to x. So x is some number that's fixed, and you're only letting n become very large, right? So what's the limit of this part?
0.
0, right? And x is some fixed number. Therefore, the limit is
0.
0. Therefore, what's our conclusion?
It's conclusive.
No.
No, it's
If
less
e-
than 1.
It's less than 1,
It
so
converges.
it converges. Okay, so
Oh, that's okay.
converges. But wait, what does that mean? What's our interval of convergence then?
Nothing.
Not nothing. Usually we had some condition on x. What is this thing saying?
The all values of x.
For all values of x, for any value of x, you're always going to get 0. Whatever x is, this it's always 0. So converges for all values of x by ratio test. So therefore, the interval of convergence is
Infinity?
convergence is from negative infinity to infinity, right? And the radius of convergence is
Infinity.